Hey everyone, Mr. Hauk here. In this video, we're going to continue looking at parabolas. So in the previous lesson, we looked at the key features of parabolas, we learned how to graph them, we learned how to find those features like the vertex, the axis of symmetry, the focus, and the directrix. In this video, we're going to be looking at if I give you certain features, like if I give you the vertex and the focus, can we come up with the equation? Or if I give you the vertex and the directrix, can we come up with the equation? Okay, so we're kind of going to be using our features to reverse engineer the equation, so to speak. So let's look at the activating strategy. Identify the features of the graph below, then write the equation in standard form. Okay, so starting first with the vertex is pretty easy to see. That's right here at 0, 0. And the p-value, so there's two ways to figure out the p-value. First off, the p-value is the distance from the vertex to the focus, but notice that we don't have the focus here. Well, the p-value is also the distance from the vertex to the directrix. And from the graph, this is our directrix, this horizontal line here at y equals 3. So the distance from our vertex to our directrix is a distance of 3. Now, the p term is not only going to be 3, but because the parabola is opening down, it's actually going to be negative 3. Okay? The negative because we're opening down. Well, the nice thing about parabolas, we only need 3 things to be able to write the equation. We need to know the direction of opening, the p-value, and the vertex. So because this particular parabola is opening down, our equation is going to be 4p times y minus k equals x minus h squared. So let's plug in the pieces that we know. We know that p is negative 3, so this is going to be 4 times negative 3. Then we have y minus k. This is just where we take the y coordinate of the vertex and we plug it in right here. So we're going to have y minus 0. Then over here, for the x minus h squared, we're going to have the x coordinate of the vertex going right there, x minus 0 squared. Okay, let's simplify things and clean it up. 4 times negative 3 is negative 12. Y minus 0, well, that's just y. And then x minus 0, that's just x, and squared. So negative 12y equals x squared. So pretty simple. Again, what we did there, we need to find 3 things: direction of opening, the p-value, the vertex. Once we have those 3 things, we can write the equation pretty easily. So let's try another one. Here in the second example, still on the activating strategy. The vertex is right here. It's the point 1, negative 2. Again, p is the distance either from vertex to focus or vertex to directrix. This distance is 3 once more, but this time the p is going to be positive 3 because it's opening to the right. Opening to the right is a positive direction, so p will be positive. Alright, so again, and we can see that it's opening to the right. So because it's opening to the right, the equation is going to be different. So this was the equation that we use if the parabola is either opening up or down. If the parabola is opening left or right, the equation is 4p times x minus h equals y minus k squared. Alright, let's plug in the pieces. P is 3, so 4p is 4 times 3. X minus h, that's coming from the x coordinate of the vertex. We're going to have x minus 1 equals this part, the y minus k squared, that's coming from the y coordinate of the vertex. We're going to have y plus 2 squared, changing the sign there, y plus 2 squared. And if we clean it up a little bit, 4 times 3 is 12, times x minus 1 equals y plus 2 squared. Okay, so pretty simple. All right, in these other examples, so again, that was the activating strategy, but what that really does, it really does a good job of illustrating what we're going to be doing in this set of notes. So it boils down to, do you know the direction of opening? Can you find the p-value? Can you find the vertex? And once you have those three things, we're going to be ready to write the equation. So that's going to be no matter what I give you. So in the other examples, example 1, 2, and 3, I'm not going to give you a graph. We're going to try to figure everything out just from the features that I tell you. Okay? So in example 1, all we're going to be told is that the vertex is 5, negative 3, and that the directrix is the line y equals negative 7 halves. The graphs are there for our visual, just for our visual benefit, okay? So I'm going to use the graph mostly to try to figure out the direction of opening, all right? So the vertex is 5, negative 3. Let's go ahead and plot the vertex. I'll plot the vertex using a blue dot. So 5, negative 3, right here. And the directrix, which is a line, is the horizontal line, y equals negative 7 halves. Now, y equals negative 7 halves is the same thing as y equals negative 3.5. So we have a horizontal line going through negative 3.5. So that would be like this. Okay. Now, using what we know about parabolas, if this is our vertex and that green line is our directrix, we can't be opening down because we can't pass through the directrix. Again, also we can't open right because we can't pass through the directrix. We can't open left because we can't pass through the directrix. We have to be opening up. We don't have any other choice. All right, so we know that this particular parabola opens up. Okay, so we have the vertex. We know the direction of opening. All we need left is the p-value. Now the p-value is the distance from either the vertex to the directrix or the vertex to the focus. We don't have the focus, so we're going to find the distance from vertex to directrix. Well, the directrix, the equation is y equals negative 7 halves, or y equals negative 3.5. The vertex is at 5, negative 3. So, I mean, let's just compare the y coordinates. Negative 3 versus negative 3.5, that's 0.5, they're 0.5 apart. The vertex and the directrix are a distance of 0.5 apart, which is 1/2. And because it's opening up, the p-value has to be positive. If it was opening down, our p-value would be negative. But it's opening up, so the p-value is positive. So now we have everything we need. Because it's opening up, the equation is going to be 4p y minus k equals x minus h squared. Let's plug in the pieces that we know. P is 1/2, so 4 times 1/2 times y minus k is going to come from the vertex. That's going to be y plus 3 equals x minus h is also coming from the vertex. That's going to be x minus 5 squared. And simplifying this up a little bit, 4 times 1/2 is 2, so 2 times y plus 3 equals x minus 5 squared. All right, let's go to the next example on the back. All right, example 2. Use the fact that the vertex is negative 5, 7, and the focus is negative 5, 15/4 to write the equation of the parabola. Again, the graph is there for our visual benefit. Let's try to plot these points. I'm going to plot the vertex in blue. I'm going to plot the focus in purple. So negative 5, 7 is the vertex. And negative 5, 15/4 is not a very intuitive point here. So instead of using that, let's convert 15/4 into a decimal. 15/4 is 3.75. So this is the same as the point -5, comma, 3.75. All right, so let's plot that. -5, comma, 3.75. That's roughly right here. So again, one of the big reasons we're using our graph is to help us determine direction of opening. This purple point is the focus. Remember that your parabola is going to open towards your focus. If my vertex is up here and my focus is below it, my parabola is going to open down because the focus is contained inside the parabola. So I know automatically that this thing opens down. Okay, so we've got the vertex, we've got the direction of opening. The last thing we need is the p-value. All right, well, first off, it opens down, so we know the p-value is going to be negative. And now we have to think, okay, well, how far apart is the vertex and the focus from each other? And I'm going to use fractions. So one thing I can look at here, so look at the vertex versus the focus. Well, the -5s are the same. I'm going to ignore those. 7 versus 15/4. Well, as a fraction, -5 comma 7, I'll use blue here, is -5 comma 28/4. 7 is the same thing as 28/4. 28/4 and 15/4 are 13/4 away from each other. And again, we've already noted that p is negative because we know that we're opening down based off of the picture that we drew. So now we have everything we need. So we know it opens down. If it opens down, the equation is going to be 4p y minus k equals x minus h squared. Plugging in our pieces, that's 4 times, our p was -13/4. Y minus k, that's coming from the vertex, that's y minus 7, equals x minus h, that's coming from the vertex, that's x plus 5, squared. All right, 4 times -13/4 is just -13 times y minus 7 equals x plus 5 squared. All right, last example. All right, use the fact that the focus is -8, -2, and the directrix, we spelled directrix wrong, directrix is x equals -6. Okay, so focus, I plotted the other focus in purple, I'll do the same thing. Directrix, I'll use green. All right, so focus is the point, -8, -2. That's right there. And the directrix is the vertical line, x equals -6. Okay. Now, again, using things that we know about parabolas, one thing we learned yesterday is that the vertex is going to be halfway between the focus and the directrix. So the vertex, we can automatically tell, is right there at -7, -2. All right, so I'm going to go ahead and list that because vertex is one of the things that we need. Vertex, -7, -2. We can see that this thing is going to open to the left, has to open left because we cannot pass through the directrix. That's one way we know it opens left. The other reason we know it opens left is that if you know where your vertex is, the parabola opens towards the focus. The focus is to the left of the vertex, so we know this thing opens left. So vertex is -7, -2. We know that it opens left, the parabola. And then finally, we need the p-value. Well, opening left is a negative direction. We know p is going to be negative. And look how far away our vertex is from the focus. It's only 1 away. So the p-value is -1. Okay, so this thing opens left. We're going to use the equation 4p x minus h equals y minus k squared. Plug in your pieces. 4p, that's 4 times negative 1. X minus h from the vertex, that's x plus 7, equals y minus k, that's from the vertex, that's going to be y plus 2, squared. Simplify stuff. 4 times negative 1 is negative 4 times x plus 7 equals y plus 2 squared. Okay. And that's pretty much that. Make sure that you're taking advantage of your graphs to plot the pieces that are given to you. Again, the biggest advantage to using the graphs to help you out here is so that you can tell the direction of opening for these things. All right, that's going to be it for this set of notes.